Hello guys, welcome to Orijit's computer classes once again. Today we will be looking through a very interesting as well as an important problem from leetcode, that is Koko eating bananas. So what does the problem states? That Koko is like an animal who has to eat n bananas from the piles, from n piles, right? Like I am directly moving to the example. Suppose say this is these are the piles array, where this is the first pile, this is the second pile, third pile, fourth pile. So first pile contains 3 bananas, second pile consists of 6 bananas, third pile consists of 7 bananas, and fourth pile consists of 11 bananas. And the total hour that is given, so within 8 hours Coco has to finish up all the bananas from all the piles, right? That means we have to return basically an integer k, which is the eating speed of Coco. Okay, so what is the optimum speed that we can decide for the Coco, within which, which Coco can opt out for, so that he can complete eating up all these bananas within the mentioned time, okay, or the allocated time. So let us go through the problem. Say this is our piles, okay. Let me increase the font size. This is our piles array. Piles array, piles, fine, is equal to 3, 6. Let me go through the problem statement. 3, 6, 7, and 11. 3, 6, 7, and 11. Okay, and the allocated time is 8 hours. Okay, so now in order to find out the speed, right? So k is our, like, bananas per hour, that is our speed, right? K bananas per hour, the Coco has to opt out a speed of k bananas per hour. So we need to consider such a value of k, so that the completion will be within 8 hours. So one, if we go through the brute force approach, brute force solution for this problem, what we can do is we can start from 1, say the value of minimum value of k to be 1, okay, and we can like heat and trial method. We will be checking out through all the values, and whichever value is covered, like the total time is covered within this h is equal to 8 hours, that is our solution. So let us check once. We say for k is equal to 1, k is equal to 1 banana per hour. In that case, see, now we know that uh, total time taken is distance by speed in general for time, work, and distance. In this case, it is the number of bananas given. So, like, bananas, number of bananas by the eating speed, number of bananas divided by the eating speed, that is k. K is the eating speed. Okay. So let us suppose k is equal to 1. In that case, for eating 3 bananas, the time taken will be 3 hours, right? Because 3 by 1 is 3. Similarly, for 6 by 1 is 6, plus 7 plus 11. Okay, so this will be the total time taken by Coco to eat. So 7 plus 11 is 18. 18 plus 6, 24, 24 plus 3, 27 hours, right? So that means it is greater than h, right? As it is greater than h hours, so k is equal to 11 is not acceptable. Not acceptable, right? Okay. So let us check with k is equal to 2. K is equal to 2. So this is our brute force approach actually. We shall be checking with all the possible values of k, and we'll be considering the one that comes within these h hours. Okay. So k is equal to 2 banana per hour. I'm writing in short form only. So for k is equal to 2, now for eating 3 bananas, it is 3 divided by 2. That is 1.5 hours, right? Now, as we have to return the solution in integer and everything is given in integer, right? So in integer value, we cannot consider like k is equal to something 1.5 after dividing 1.5. So we can take the max because if Coco is taking 1.5 hours, so that means it is approximately taking 2 hours. We will be considering that only. The round off, that is the seal value of this t, right? We cannot consider pointed or decimal values of t, right? Because we are considering integers here, right? Therefore, we will be considering the rounded value. So approximately if it is 1.5, so the ceiling value of 1.5 is 2. So 3 divided by 2, it is approximately taking 2 hours for 3 bananas. Similarly, for eating up 6 bananas, if the speed is 2, so 6 by 2, it is 3 hours. Fine. For 7 bananas, it is 7 by 2, 3.5 again. So 3.5 means ceiling value 4 hours. Okay. For 11 by 2, 5.5, that is 6 hours. So total it is taking 2 plus 3, 5, 5 plus 4, 9, 15 hours. So 15 again greater than h. That is the given time limit. So we cannot take that. 15 is again not acceptable. That means not 15. 15 is the total time it is consuming. That is 2 banana per hour is not acceptable because it cannot complete eating up all the bananas within the allocated time, right? So again we go for k is equal to 3 banana per hour. In that case, so in first case it is 3 by 3, that is 1, plus 6 by 3, that is 2 hours. 7 by 3, again it is 2 point something. So 2 point something is, again we round off to the ceiling value. So it is 3 hours. 11 by 3, 3 point something. Again we round off to the ceiling value. So 4 hours. Okay. So 4 plus 3, 7 plus 2, 9, 10 hours. So 10 is greater than h. Okay. Therefore, 3 is also not acceptable. Not acceptable. Fine. Okay. Now again, k is equal to 4 banana per hour. In this case, so again, 3 divided by 4. So that is 0.75. That means 1, rounded off to 1. 6 divided by 4. So that is 1.75. Okay, rounded off to 2. 7 by 2. That is again some 1 point something. So that is also rounded off to 2, right? 6 by 4 is 1.5 and 7 by 2, 6 by 4 is 1.5. Then 7 by 4 is again rounded off to 2, and then 11 by 4, that is 2 point something. So 3 hours approximately. Okay. So 3 plus 2, 5 plus 2, 7 plus 1, 8 hours. So it is taking exactly same time as h. Therefore, we accept. So k is equal to 4 is the accepted solution for the given set of piles. Therefore, they are returning 4 as the output. As you can see, 4 is our output in this case. So this value of k is returned by the given function, right? Minimum eating speed. That is the name of the function they have given. Fine. Now, you might be thinking that if the total time, added time, is exactly equal to h, then only we will be returning the k. But that is not the case. Uh, Coco can have such an eating speed, considering which it can actually the finish eating up all the piles less than within in such a value that is less than 8 hours. Okay, the given value. So in that case, that is also an acceptable solution. So if t, here t is the actually required time that we are considering, right? So required time, I am writing in short, req time, required time. So if t is less than or equal to h, in such a case we shall be returning k. Fine. Okay, that is one point. Okay, now another thing, you may be thinking also, right, like that, suppose say even if k is equal to 5, after, I mean after 4 whatever value of k we consider, that will always come, I mean the required time for that value of k will always be less than h, right? Like say if we consider k is equal to 5, k is equal to 5, in that case also we are getting a value k is equal to 5. So 3 by 5 is something called 0.6, that is 1. Then again 6 by 5 is 1 point something, so that is rounded off to 2. 7 by 5 is rounded off to again 2, and 11, that is also 2. Fine. So 2 plus, that is 6 plus 1, 7 hours it is taking, that is less than h. So in such a case, we should also have accepted 5, and anything that comes after 4 in this case will be accepted. I mean, like it is always less than h, right? The required time comes out to be less than h. But what the problem asks is, we need to find out some minimum value of k that is within which it can eat, right? That is the critical value, we can say. 4 here is the critical value. So we need to return that critical value. After that critical value, whatever value of k we take, that will always be acceptable, right? But we need to return that particular critical. So at least what should be the eating speed of cocoa, so that it can complete it within the 8 hours. Okay, at least the minimum speed, or if you can ask yourself the question, what at least what speed the cocoa should opt out, that is 4, at least, at minimum. Okay, fine. After that, it I mean whatever value you take, all will be acceptable, but 4 here is the critical value. Same in other cases also. In this file, if you test it by yourself, so 30 is the critical value within which cocoa can finish eating up all the bananas from all the piles. Okay, fine. So this was our brute force approach, where we are considering all the values of k. Okay, and wherever we are finding the proper value of k that is acceptable, where the required time for whatever value, the required time is becoming less than or equal to h, we are returning that value of k. Okay, now the problem here is, you may ask that where should we stop? Like, there can be instances where we never find out a speed, right? Where we never find out an optimum speed within for which Coco can finish eating up all the bananas within the allocated time, and in that case, we will be returning -1. But in such a case, we cannot run an infinite loop, right? Because we are just considering random values of k from 1, and we are going up till as if up till infinity. In suppose in places where we are not finding out any value of k that is less than, for which the required time comes out to be less than or equal to h. Okay, in such a case, up to which value k will go. Okay, so that is our main motive, where the loop can stop. Okay, so first we are starting from 1. Starting value is 1, then 2, then 3, up to n. That n will be this maximum value in the array. Okay, that means in this case we can go maximum up to 11. See why I am saying so. That means in this case arrays, if the k in this problem, maximum value of k can be 11. Okay, maximum value of k, maximum value of k can be 11. Okay, and it can go even more than 11, but we are considering up to 11 because see, at most what we can do, Coco needs minimum 1 hour, we are considering, to complete finish up eating all the piles, right? So whatever be the maximum value of, I mean, in the array, maximum, the pile which is consisting of the maximum number of bananas. Okay, that is where Coco is taking maximum time, right? It is obvious for any one of us, the place, the portion where we are having maximum task, there we take the maximum time, right? Therefore, that means for eating up here, the maximum value is 11. For eating up 11 bananas, Coco will be taking maximum time, right? In this case, for 30, eating up 30 bananas, Coco will be taking up the maximum time, right? Uh, the maximum, the more the task is, the more is the time taken. Therefore, we will be considering the maximum value of k to be 11, because at most it can take, if it is 11 bananas per hour, then the then we are getting the minimum time. Okay, fine. If say the total distance we need to travel is say 150 kilometer, so if I can make the speed of the car to be 150 kilometer per hour, so that is the max highest speed of the car, right? Because we will be starting, and at the same time we will be reaching the final position. It is something like that. So at most it can, if the speed of eating bananas is 11 banana per hour, within that it can complete, because it will just start and finish up all the bananas. It is as if something like that. It is an arbitrary with you are assuming. It doesn't happen, but maximum k can go, theoretically maximum k can go up to the maximum value present in the array. Fine. Okay, so now let us code it down. So this is our function given to us. Fine. That means, so we will be running the loop till the maximum value in the array. So we are, at first we let us take a maximum. So this maximum will take out a function. So it will be accepting the piles array, and it will be accepting the size of the array definitely. What will this function do? This function will be returning us the maximum value present in the array, right? The maximum value present in the array. So we need to define this max function first. So it's a int max. It is accepting an array, say int p, taking int p, comma, int size. So size is the total size of the array, total number of piles we are having. So for in I is equal to 0, first index of I less than what to the size of the array, I plus plus. Hope you know how to find out the maximum value out of the array because as you are watching this placement series, so it is expected from you that you already know how to find out because these are the basic things, right? You have learned in your first year or something because when you have started coding, these are the first things that are being taught to you. Fine. So if p of I greater than the present value of m, so in the present something, let us consider a variable that is storing the maximum value p of 0. Initially say it is holding the first value of array. If p of I greater than m, in that case we will be storing the value in m, right? P of I. Fine. If p of I greater than m is storing, and in this way m will be holding after the loop completes, m will be holding the maximum value of the array. Okay, and let us see if running this loop is feasible, because if the value of size is no, okay, so piles dot length is can maximum go up to 10 to the power 4, and even if it is 10 to the power 4, that is 10,000 iterations, it can finish up, okay, within the allocated time. Okay, 10,000 iterations is okay. Now as we are considering the brute force approach, so we will be starting from what value of k we were starting. K is equal to 1, right? So let us consider a loop of k where the loop variable is k is equal to 1, k less than equal to this max, because this max is holding the maximum value of the array, right? So maximum, that means the maximum task the Koko can do. So k less than equal to max, k plus plus, opening brace. So there should be a variable, so say t, that will be storing, where we will be finding out the maximum time, that is the required, I mean the required time, not the maximum time, my bad, the required time, that is after adding all these values, after dividing consecutive values in the piles, total time that is taken, so the required time that we will be holding in t. Fine. So in t, it will be, say, considering a function that gives it the value. So it will be accepting the piles array and the pile size. Fine. So this function will be returning the required time. Okay. So if that required time is less than or equal to h, so we will be returning that k. Fine. Or let us break it here. If the t is less than equal to h, let us break the loop and we will be returning k. Or let us just return the k here. Return the k here. Fine. So we are returning the k here, because after that there is nothing to do. When it finds a required time to be less than equal to h, that means that is the solution. Fine, that is the critical, at that particular moment we are finding, because when we are considering all the values starting from 1, it will reach up first, it will reach up the critical value, and as soon as we reach that critical value, we will be returning that. After this will go out of the function, and wherever the main function is written, it will return that value. And now, if no critical value is being found, or no speed of Koko is possible, by which it can eat complete eating up all the bananas within finish up all the bananas within the allocated time, that is the age. In such a case, we will be returning -1. Fine. Okay. So that's it. So that is our solution. Fine. Now, so the solution is not yet complete. We need to define this required time function. Fine. So that required time function, int time. So what it is accepting? It is accepting two values. That is the piles array, and the size of the array, definitely. Okay. Now it will be taking up a variable, definitely, because what we are doing, we are just summing up. See, when we are finding out the required time, we are actually dividing each of the values by the k, the speed, and we are adding up, right? So it will be taking up another parameter. So that is the k. So k is basically the eating speed of Koko. K is the eating speed of Koko. So speed, I am considering it to be speed. Now, so in among the piles array, we are considering size and taking up the eating speed, eating speed, and for int I is equal to 0, I less than size I plus plus. Fine. And what we are doing, we are checking up with all the values, we are just dividing. So t is equal to t plus whatever be the piles, I mean, in the piles array, the value that, because that is the bananas, number of bananas it is consisting of, right? So p of I divided by the eating speed of Koko. That's it. And now we are considering the ceiling value. So ceil of p of I by speed. Fine. I hope it it is absolutely okay. So it will work fine. So up to the size, and so return the value of t. So this capital T is the required time, and this capital T, when it is returned, it will be stored in the small t. Okay, for each value. So okay, so this is our okay. So this is our solution. So let us run the code. But one thing is for very sure, this code will throw wrong answer for the first instance. Uh, why? The answer I want to know from you guys. See, this is actually no, this is compile time error. This is something because of the data type int max. Okay. See, at the first instance, it throws a wrong answer. Now just uh, guess why it is. So I give you, just pause the video and think for 5 to 20 seconds, and just say why it is throwing wrong answer. So which part of the code I have made a mistake. So I want you to identify. For your hint, I want to say that the mistake is in this required time function. Okay. And what is that mistake? Okay, done. So ready. So int required time, everything is correct except that, see, I am performing the ceil function, and this is p of I is an integer. Similarly, the speed that is received in this function is also an integer. Okay, and integer by integer returns an integer, and ceil function doesn't work for integer values, right? Because for ceil function to work, it should at least have 2.33, 4.5. But if it gets exactly 2 or exactly 1, Fine. So then ceil function returns 1 only. Fine. After decimal, it should have decimal values. Okay, decimal points inside it. So output that we are getting is 3. So what is happening for k is equal to 3? Uh, so basically 3 divided by 3 1, plus 6 by 2 is 2, 1 plus 2 3, 7 by 3 is again 2. So it's 3 plus 3 6, and 3 9. I mean, so that is also 3 divided by 3 is 1, 1 plus 6 by 3 is 2, 1 plus 2 is 3, and 7 by 3 is 2, 2 3 plus 2 is 5, 5 plus 3 8. So 3 it is getting as the optimum speed of Coco, which is not right. Now in order to correct this, what we can do is we can just typecast it to float, nothing much. Typecast it to float. Fine. So let us see. Now it should, we should be get the correct value. Just hold. Yeah. So now it is accepted. So for this test case, it has accepted our solution. Now let us check the constraints. See, the maximum value can go up to, like say 10 to the power 9. So let us just convert it to long data types to long, so that what can happen, uh, it can at least accommodate the values in the variable, right? So because integer cannot hold, we can expect something very huge value, because see, the file length can go up to 10 to the power 9. Okay, in order to, and the required time after addition can also go very long. Okay, and long. Fine. Here also it is long. It is also long. Okay. Now, so let us submit it and check. We are supposed to get, yeah. So actually, see here the values are very huge. So even long is, we need to make it work with the higher data type. So yeah, okay. This also needs to be changed to long. Okay. So the required time must be accommodated within the value. Fine. See, so this is what we are getting for this solution. Time limit exceeded error. Okay, that is the runtime error, because naturally this is the brute force approach I was talking about. So within the allocated time, this program couldn't run. So this is your assignment to think of the optimized solution. Let us discuss the time complexity of this code. So see, we are actually running a loop from k, I mean 1 to max, and if we look at the constraints, the piles dot length can go up to 10 to the power 9. Fine. So the if, and even as well as piles of I, as it is going up to 10 to the power 9, this is 10 to the power 9 piles dot length, right? Piles dot length, piles dot length is equal to 10 to the power 9. Maximum we can have the value of piles dot length to be 10 to the power 9. Fine. And we are also the piles of I. So we are considering the maximum value of the array. So that maximum value can also go up to 10 to the power line 9, right? So the time complexity of this code is apparently looking to be big O of maximum of array. Fine. Or that is also very huge, but that is not the case. It is not only big O of maximum of array, but also it is multiplied by n, because for the calculating this required time, we are running another loop up to the size of the array. So big O of maximum of array into pile size. Pile size is size. Basically, you can also consider n, that is the size of array. So it is resulting into a very huge time when this such huge array is given to it, right? So for that, we need to optimize our code. So first, you try to think which approach can be used, I mean, which methodology can be used to to optimize this code, right? After that, just wait for my next video. I will be bringing up. For now, I can just give you a hint. We can use binary search technique in this case, right? Now, how to use the binary search technique, that I want you guys to think of. Okay? So that was for this lecture. That was all, right? So bye bye. Take care. Have a good day.